All right, y'all. So, there is a possibility that I will not be in class tomorrow or even a couple of other days this week. So I went ahead and made a couple of videos that, in case I am not there, y'all are able to continue to stay on track with our lessons, to stay on track with our pacing and our test. So what we're going to do today is test 3, lesson 4 on polynomial theorems. Okay, so basically what we're talking about most of the day is roots and zeros. So just so you understand, a root of the equation is a zero of the associated function. Okay, so a root of an equation is the zero of the associated function. All right, so when it asks for a root, if we have the equation y equals 2x plus 2, and we were to solve this out, let's see if I have a pencil. I think I have a pencil. And we were to solve this out, then we would end up with -1 as a root. Okay. However, if we turn this equation over here into a function, we do that with our f of x, okay? And then we solved it out. Now we would say that -1 is a 0, okay? So if you think about this, the way we would solve this basically is we would put in 0 for y. Okay, so move the 2. That's where you would get it for both of these. Okay, but over here on the function side it's a 0, and over here on the equation side it's a root. All right, so using that, we're going to move forward. All right, so for f of x equals this really long polynomial, we want to find f of 2. And we have done several of these over the last few weeks. So all we're doing here is we're plugging 2 in everywhere we see x. So f of 2 is going to equal 5 times 2 to the 4th minus 2 times 2 cubed plus 3 times 2 squared plus 4 times 2 plus 9. Okay, you got calculators, you can plug all that in. I'll simplify it out a little bit for you here. 2 to the 4th is going to be 16. 16 times 5, it's going to give me 80. 2 cubed is 8. 8 times 2 is 16. 4 times 3 is 12 plus 8 plus 9. And if you add all of that together, you are going to get 93 as your answer. Okay, so there's a couple of other ways that we do this. And again, we've talked about how sometimes you've learned some of these things before, and then there might be a method that you're not familiar with. That'll probably happen again here today. Okay, but one thing that we are going to talk about first is synthetic division. Okay, synthetic division. That's a lie. It's not a lie. I was ahead of myself. Synthetic substitution. Okay, so for synthetic substitution, we're going to use our coefficients. Okay, so just be reminded when we're talking about coefficients that look at your highest exponent, make sure you have one of every single exponent that there is. So for instance, this one's starting with a 4. So I need to make sure I have a coefficient for 4, 3, 2, 1, none. Okay. If any of those are missing, you do have to put a 0 as a placeholder. So for synthetic substitution, we're going to take our number. It's going to go up here in our little box. And then our coefficients from the problem are going to go across the top row. So 5, -2, 3, 4, and 9. Again, I went 4, 3, 2, 1, none. So everything's just straight across. All right, draw me a little line down here. Okay, the first one simply comes down. All right, and then we're going to multiply and add. So 2 times 5, it's going to give me 10, and we're going to add -2 plus 10 and get 8. 2 times 8 is going to give me 16. 3 plus 16 gives me 19. 2 times 19 gives me 38. 4 plus 38 gives me 42. And 2 times 42 is 84. And 9 plus 84 is going to give me 93. And 93, if you look, is the same thing that I got up here. Okay, so you're multiplying to fill in the second row here. Okay, so 2 times 5 is 10, 2 times 8 is 16, 2 times 19 is 38, 2 times, and then we add on our columns. Okay, so again, you could say f of 2 is 93, which is the same thing we had up here. All right, so we're going to use that process for example number 2. Now, if for some reason I am not there and you are using this video as the sole way for me to teach you how to do this, all right, it's going to be very simple for you to just continue to copy what I'm doing. But after we go through a couple of these, or I go through a couple of these, you need to probably pause your video, try one of these on your own, and then go and check and make sure that you have the process, the understanding down, okay? You don't just want to sit there and let me continue to do all of them for you and you just copy, okay? All right, so here we go. We're doing g of -4. Here's our g function right here in the instructions. So we're doing g of -4. So -4 is going to go in my box, and then my coefficients. All right, so I have 2 is my squared term. I have -3 is my x to the first term, and then I don't have a constant, so I have to put a 0 as that placeholder. Okay, first one drops down. -4 times 2 is -8. That gives me -11. And then -4 times -11 is positive 44, which gives me an answer of 44. So that's all I'm looking for. Okay. And you'll see here in B and C that we can do different things. It's not always just a constant number. All right, so we're going to do g of -2x here. All right, so that means -2x, process is still the same, -2x goes in the box. And we're still using 2, -3, and 0. Okay, oops. So 2 comes down. All right, so -2x times 2 is -4x. So you're adding -4x and -3. So we know we can't put those together, so we're going to leave it -4x minus 3. And now we're going to multiply -2x times -4x, which is going to give me positive 8x squared. And -2x times -3 is going to give me positive 6x. And since we're adding that with 0, that is going to be our final answer for this problem. 8x squared plus 6x. Again, pause the video when you need to. Okay, so right here we're going to try g of 3i. So that means 3i is going to go in our box, and we're still using 2, -3, and 0. So here we go. All right, 2 comes down. 3i times 2 is 6i. -3 plus 6i is going to be 6i minus 3. You can do -3 plus 6i, it doesn't matter. Okay. And then we're going to do 3i times 6i minus 3. All right, so I'm going to go over here real quick and just work that out so you can see what that's going to be. So we're doing 3i times 6i minus 3. Okay, so if I do 3i times 6i, remember, that gives me 18i squared minus 9i. And we remember that I squared is the same thing as -1. So that's going to turn into -18 minus 9i. So that is what's going to go here. Oops, sorry. All right, and then again, adding that to 0, so our final answer is going to be negative 18 minus 9i. All right, so that's synthetic substitution. Students usually actually pretty much like that method because it isn't insanely difficult, and so it's something they do grasp. All right, but then we're going to move into example number 3. Okay, and we're going to be dividing here x cubed plus x squared minus 10x plus 8. And we're going to divide that by x plus 4. All right, so we are actually going to do this the long division way. And the long division way, it does take a little bit of work and it takes a lot of thought process. Okay, y'all may not remember long division. So I'm going to come over here real quick and just do a simple long division problem just to remind us. Let's say we had to put 5 into 763. Okay, so if you remember doing this long division ways, we see how many times will 5 go into 7, and it was 1. 1 times 5 is 5, and we subtract. Bring down my 6. 5 goes into 26 5 times. 5 times 5 is 25, and we subtract. Bring down my 3. 5 goes into 13 2 times. 5 times 2 is 10. Subtract, and we have 3. So then we would take this, be our numerator. This will be our denominator, and the answer was 152 3/5. Okay, so similarly, we're going to be doing this, but there's going to be variables involved as well. Okay, so here we go. Buckle up. We're going to use x plus 4 dividing into x cubed plus x squared minus 10x plus 8. All right, so here we go. How many times will x go into x cubed? So x times what gives me x cubed? Well, we've got a 1 here and a 3 here, so we're missing 2, so it's going to be x squared. Okay, so now we're going to do x squared times x is x cubed. X squared times 4 is 4x squared. Okay, so here is where people get confused on long division. Remember, over here, we just brought down 1 times 5 is 5, and then we put a minus sign. Okay, we did 5 times 5 is 25, and we just put a minus sign. Okay, so we can put a minus sign over here, which is what I'm going to do, but you've got to remember that you're technically distributing that minus. So it's going to be x cubed minus x cubed, which does cancel. That's the whole point. But it's x squared minus 4x squared. So that's going to give me negative 3x squared. All right, bring down your 10x, your minus 10x. So now x times what gives me negative 3x squared? Negative 3x. So now we're going to multiply. Okay, negative 3x times x is negative 3x squared. And negative 3x times 4 is negative 12x. But remember, we are subtracting those. So technically, these are going to turn to a positive. So now these cancel. And negative 10 plus 12 is going to give me 2x. And we're going to bring down our plus 8. So then how many times will x go into 2x? Well, x times what gives me 2x? So the answer there is 2. 2 times x is 2x. 2 times 4 is 8. But remember, we're subtracting, so that cancels that. So 0 is my remainder. All right, so here's what you got from there. This right here, this is called our quotient. Okay, this that we divide into is called our dividend. This that we divided by is called our divisor. Oh, sorry. And then whatever is left is our remainder. Okay, so this is long division. It's confusing. A lot of people forget their negatives. Stick with this. Okay, same rules as these over here. It's just got letters involved. All right, but then we're going to do example 3 synthetically. Okay, so what I mean by synthetically is this tells me right here, okay, that x plus 4 is my divisor. So if I'm trying to find the 0 of that, I need to do the opposite of that. So the number that's going to go in my box here is actually going to be -4. Okay? That is the 0 of our divisor. So if it's x plus 4, then -4 would make that 0, so that's what we put there. All right, let's look at our numbers. 1, 1, sorry, coefficients. 1, 1, -10, and 8. So 1, 1, -10, and +8. All right, here we go. Draw my line, drop my first number down. -4 times 1 is -4. That gives me a -3. -4 times -3 is +12. That gives me a 2. -4 times 2 is -8, and that gives me 0. So this is now my quotient. This is still my remainder. So now how do we write our answer? Well, we start with our last, not our remainder, our last number being x to the 0 power. So that's our constant, okay? And then we're going to go back and throw our x and x squared in. All right, so our final answer here would be x squared minus 3x plus 2. Okay? So again, your remainder is just a constant number. Sometimes it'll be a fraction over what you divided by. But then right here starts our x to the 0, x to the first, x to the second, because it should always be one less than what you started with. Okay. All right, so that takes us right down here to just some theorems that we have based on this one. A polynomial p of x is divided by x minus r. The remainder is p of r. Okay? All right, the factor theorem says for a polynomial p of x, x minus r is a factor if and only, this means if and only if p of r equals 0. Okay? All right, so here we go. If x equals 2 is a root of the polynomial 2x cubed plus 5x squared minus 23x plus 10, find the remaining roots. So here's what we're going to do. If it tells me it is a root, all right, we're going to start by putting this in the box and simplifying out. All right, so we got 3, 2, 1, none. All right, so we're going to go per 2, 5, negative 23, and 10. All right, let's see what we got. Bring it down, bring it down. 4, add, that's 9. 18 is -5. Negative 10 is 0. Okay, cool. So because it gave us a 0, we do know that that 2 is a root of this polynomial. Now we need to find the remaining roots. Okay, well, a couple of ways we can do that. Let's look what we got here. Okay, this is going to give me 2x squared plus 9x minus 5. So let's start there. So this x equals 2 gave us x minus 2. And now this one's going to give us 2x squared plus 9x minus 5. Okay, well, we already know. We've already figured this one out. This one right here, it's going to give us 2. We already know that. So can we xbox this and factor? Let's see. 2 times -5 is -10. 9 in the middle. That's what, 10 and -1? And then those have to be divided by the 2 we multiplied by. So it's going to be x plus 5 and 2x minus 1, which give me the zeros -5 and +1/2. So when it says find the remaining roots, -5 and +1/2 are your answers. Okay. All right, last page, last page. Last page, last page. What do you do, though? That one, they gave us the starting point. Like they said, hey, x equals 2, right? Come back here. They said, hey, x equals 2, right there. I'm telling you, x equals 2. So try that and get it down to a binomial that you can factor. But what do we do if they don't give us any of that? All right, don't be overwhelmed by all this right here. It's just talking about the way the polynomial function works, where it's one less power each time you go down, okay? So let b of x be a polynomial in the form of, like, this will be 7x squared plus, you know, whatever, okay? If, let's fill in our vocabulary, if x equals p over q is a rational number where p and q have no common factors other than 1 and the factor that's equal to 0, then p must be a factor of a0 and q must be a factor of a n. All right, what does that mean? All right, well, let's put that to a problem, okay? All right, so I'm going to start with an equation. All right, so let's do 3x cubed plus 8x squared minus 9x plus 2, and we're going to set that equal to 0. Okay, so exponent of 3, then ultimately we should have 3 roots, okay? Nothing's given us. We can't really factor by grouping here. You can't QF it because we don't have 3 terms. We have 4. There's just a lot going on here for what we can't use our simple solving for. All right, so we're going to go into the factors of Q, all right, and the factors of P. So Q is your very first number, your leading coefficient. So we're going to find the factors of Q. Well, that's easy. The only factors of Q are 1 and 3, but we know we can have plus or minus of either of those and still get a positive or a negative depending on what it is. All right, same thing. Q is your front number. P is your last or your constant number. So factors of P in this situation for 2 are plus or minus 1 and plus or minus 2. All right, so if we make the ratio of P over Q, all right, so stick with me here. This is a lot of work initially, all right, but then it'll make sense in a little bit. Okay, so the ratio of P over Q. So if I take 1 and put 1 over 1, that gives me 1. If I take 1 and put 1 over 3, that gives me 1/3. If I take 2 and put 2 over 1, that gives me 2. And if I take 2 and put 2 over 3, that gives me 2/3. So there's 8 roots here, and we are guaranteed that at least one of them is going to work. Okay? We hope. So these are all of your possible rational, we could always have imaginary, remember, roots. All right, so let's see what we got. Let's pick one. You know what one's the easiest one to pick? 1. Okay, so I'm going to pick 1. We don't usually mess up too bad on our math for 1. So I'm going to pick 1. Okay, so we got 1. All right, so if I do 1, it's going to be 3, 8, negative 9, and 2. 3, 8, negative 9, and 2. So let's see what we get. Y'all should be okay with this by now. Okay, it didn't give me a 0. So is it a root? Nope. All right, you know what's next? Easy pick. Negative 1. Let's try that one. 3, 8. Miss Johnson, how is there a shortcut? There's not. You just pick and choose. I don't choose my fractions unless I have to. So here in a minute, I'll do one with a fraction just to show you. But if I was doing this without knowing any of the answers, I'll do plus or minus 1, plus or minus 2 before I even went to the others that are fractions, okay? All right, so bring it down. 3, negative 3, 5, negative 5, negative 14, 14, and 16. So again, so 1 nor negative 1 are roots. All right, well, let's go over here and try something else. So I'm going to try 1/3. Okay, And it's 3, 8, negative 9, and 2. 3, 8, negative 9, and 2. So let's see what we got. Bring down the 3. Well, a third of 3 is 1. 8 plus 1 is 9. A third of 9 is 3. Negative 9 plus 3 is negative 6. A third of negative 6 is going to be negative 2. Oh, ding, ding, ding. We got a 0. So we know that 1/3 is a factor. Now, once you get that, you can take this and write out a trinomial. Okay, I can divide everything here by 3, so x squared plus 3x minus 2. Well, minus 2 and plus 1 is not going to give me 3, a positive 2 and that. Okay, so this isn't going to be our rational numbers as much as it's going to, we're going to have to use the quadratic formula. So let's see what we got if we quadratic formula this. So remember our song, opposite B. So negative 3 plus or minus square root B squared, which is 9 minus 4AC. A is 1. And C is negative 2 all over 2A. Okay, simplify that up. So 3, that's 9 minus 9 plus 8, right? Because that's double negatives right there. So 9 plus 8. So x is going to equal negative 3 plus or minus the square root of 17 all over 2. And that is going to be our other roots. There's 2 there, plus 1 there. There are our 3 roots. So to write those out, the answer is 1/3 and plus or minus, I'm sorry, negative 3 plus or minus the square root of 17 over 2. Okay? All right, last example. Last example. I can't even see how long I've been talking. Okay, I know that on my end it is almost midnight. And again, I told y'all I'm only doing this because there's a possibility that I'll be out some this week. Harper had an accident this weekend and broke a bone, so we are dealing with that this week. So that's just on the safe side. I pre-recorded some stuff in case I'm not there. We're not missing instructional time. All right, so let's go using our rational root theorem, which is our P's and Q's. Okay, ever heard anybody say be on your P's and Q's? Yep, there we go. P's and Q's. All right, rational root theorem for x to the 4th minus 10x squared plus 9. Okay, so let's see what we got. Q is our first number. So Q is 1. So the only thing for 1 is plus or minus 1. And then P is our last number, so that's 9. So that's plus or minus 1, 3, and 9. We can do 1 times 9 or 3 times 3. All right, so then our P over Q ratio is going to be 1 over 1, 3 over 1, 9 over 1. So that's just plus or minus 1, plus or minus 3, and plus or minus 9. All right, where do we start? Okay. If y'all are watching this, okay, meaning I'm not there, okay, pause it. Start with 1 and pause it. So go ahead and start with 1. Put your 1 in your box. Put our coefficients, okay, so we know it's 1. All right, there's no cube term, so that's going to be a 0. Then there's a negative 10. There's no x term, so that's a 0, and then 9. So now we can fill it in. All right, pause it here and finish it out and see what you get. I'm pretending I'm paused. Okay. All right, you're with me here. 1. That gives me a 1. That gives me 1. That gives me 1. Negative 9. Negative 9. Negative 9. Negative 9. 0. Man, that's a lot of 1s and negative 9s. Okay, so now this was to the 4th, so that means this is cubed. Okay, so now I could go again, though, just using this, y'all. This is where the P and Q theorem works out wonderfully. So I can use these 4 numbers right here, and I'm going to go back and I'm going to pick negative 1. So I'm going to use 1, 1, negative 9, and negative 9. Bring it down. Negative 1 is a 0. 0 is a negative 9. 9 is a 0. So I've already got 2 roots. I've already got 1 and negative 1. And now if I look at my trinomial down here, it's going to be 1x squared plus 0x minus 9. What is that? Difference of squares. Okay, so x squared is going to equal 9. Take the square root and x equals plus or minus 3. So our roots are plus or minus 1 and plus or minus 3. Okay, so we are done with the notes for today. You will have the remainder of class to work on your homework, and we will I'll keep y'all posted on how everything's going, and I hope to see you tomorrow.